Okay, this last section of chapter 4 is 4.8. It's called the remainder and factor theorem. So the remainder theorem is if a polynomial, which we would label as p of x, is divided by r of x minus r, okay? The remainder is a constant, which aka is your remainder. We represent it by p of r. And we can make this equation. P of x, again, that's your dividend, the thing we started with, equals q of x, that's your answer, times x minus r in parentheses, that's the thing we divided by, plus your remainder, which is p of r. So that's the equation right there. So it's given to you because sometimes you have to write the answer in like equation form, which is why we give this to you. Okay? A little note to remember is that q of x is always one less degree than p of x, right? Because when you divide, whether you use long division or synthetic division, which we've already done in past sections, right? You're always one less degree. Okay. We can use synthetic division to evaluate a function. This is called synthetic substitution, technically. We can basically just use function substitution, which we've done before. So for problems like this, if f of x equals 3x to the fourth minus 2x to the third plus 5x plus 2, and it says find f of 4. So remember, f of 4, so 4 is in place of x. So yeah, you could use substitution, it means synthetic division, but why do that when you can use, they call it synthetic substitution, really means substitution. So plug 4 in for all your x's into your equation using parentheses. So 3 of 4 to the fourth minus 2 times 4 to the third plus 5 times 4 plus 2. Plug that all in. Type it in directly that way with parentheses and all powers and everything into your calculator. You should get the same answer as me, which is 662. So you'd write your final answer as f of 4 equals 662. It's that easy. I know they use a different name, but literally we've already done this, right? So here's 2 more examples. They're both f functions. And then you say find f of -1 or find f of 3. And then all the way to the right over here are the answers. So try these, plug these numbers in, see if you get the same answers I have. You can pause it, look at it. Okay? The next theorem is called the factor theorem. Okay? This is basically the remainder theorem, but it's used when the remainder is 0. And that's important because that's when we find all the zeros of a polynomial. So if you're given a polynomial to the degree of 5, you can find every 0 there is without using a calculator. Okay, because they want you to show that mathematically you understand how to do this. So this is what they look like. Determine whether x minus 5, that's a 0, right, is a factor of this function, x to the third minus 7x squared plus 7x plus 15. Okay, so find the remaining factors of the polynomial. So first we have to do the first part. See whether x minus 5 is a factor of that polynomial. It will be a factor if, when we do synthetic division, which is good for some people because they haven't learned it yet, right, or they didn't do it well the first time, then if this works and we get remainder of 0, then yes, it works. Then after that, we look at that and it's going to be 1 less degree, so it'll be squared. Can you factor it or factor by grouping or difference of squares, or can you do anything to break it down all the way and then write all the answers? So we do synthetic division, right? X minus 5, you set that equal to 0, you get 5. Put that in the box on the top. Take all the numbers from the original polynomial and put them in front. So 1, -7, 7, 15. Make sure if you're missing a degree, you put 0 in for a spot. We're not missing one here. Reminder, bring down the first term. Then you go the box term times the first term. 5 times 1 is 5. Put it in the diagonal up top and then add them together. Synthetic division uses addition. So then -5 plus -7 plus 5 is -2. Again, multiply the box term times the answer. 5 times -2 is -10. Add them together, you get -3. 5 times -3 is -15. 15 and -15 is 0. So yes, this works. So right next to it I wrote yes because P of R equals 0 because that's my remainder, right? So, and you could use their terms they have. And then my leftover is x squared minus 2x plus 3. Because remember, we just put our terms back in, 1 less degree, and then go down from there. And go, can I break this down? Or all those factoring rules, because they never go away, can you break these down? Okay, so then you go, this is a trinomial. So what times what makes this last number and adds up to be the middle number? Okay, well, it's 3. That's a good thing is there's not much that makes 3 other than 1 and 3. So negative 3 times 1, if I add those together, do I get negative 2? The answer is yes. So then those are my two sets of binomials, x minus 3 and x plus 1. So those are my sets. So then you write over here, I wrote, so my original polynomial equals these 3 sets of binomials, because those are the 3 factors of the original. So I took the one that they gave me, because it worked, and then the 2 I found, and I just wrote them. The order does not matter here. I think in the book it wrote the one they gave us first and then the other 2. It does not matter because it's groups of multiplication. Just make sure you put the 3 groups over there. Okay? So then here's another one. Hope you can see it. Yeah, you can. Okay. So show that x minus 2 is a factor of this polynomial, x cubed minus 7x squared plus 4x plus 12. Again, and then it says find the remaining. So we're doing all of this again. So again, x minus 2 set equal to 0 is positive 2. Bring down my coefficients. I got 1, negative 7, positive 4, positive 12. Bring down the first number, multiply the box times the answer, diagonal it up, add them together. Box times a negative 5, diagonal it up, add together. 2 times negative 6, diagonal it up, you add them together, you get 0. So yes, it works. So yes, right? Right, yes. And then P of R equals 0. And then my original answer, my leftover answer is x squared minus 5x minus 6. Well, I had to move over because I don't have any room. So x squared minus 5x minus 6, again, 6 is a nice number. What times what makes negative 6 and adds to make negative 5? That should be easy because 6 does not have a lot of options. I got x minus 2 and x minus 3 because they both had to be negative. Because negative 2 and negative 3 add to be negative 5. So then my answers are, I have a x minus 2 up here, an x minus 2 here, and an x minus 3. So these two, right, this is the same thing, right, written twice. So I wrote x minus 2 parentheses squared, because that means I have 2 of them, right? Saves me a little time writing. And then x minus 3. You could technically write them both out, but technically, knowing where you are in this class, you should be writing the simplified version. Okay. The next problem, this guy down here, says show x plus 4 and x plus 3 are factors of this bigger polynomial. X to the 4th plus 9x to the 3rd plus 23x, I'm pretty sure that's supposed to be squared, I just didn't write it, plus 3x minus 36. So I have 2 of them I have to show. That means you're going to have to do synthetic division twice. After you do that, then you'll be able to factor, okay? So it doesn't matter which one you do first. I just go left to right, which one they give me. So x plus 4 is first. When you set that equal to 0, it's negative 4. So I put negative 4 in the little box. Bring down my numbers. 1, 9, 23, 3, and negative 36, because that was my original polynomial, okay? Then you do the same thing. Bring down the first term, multiply, diagonally put the answer, add. Multiply, diagonally put the answer, add. You do that, you should get a 0. Now, after that one, so yes, that one worked. After that one, you take those numbers, instead of writing it, don't write the answer. You just basically remake a new, starting here, remake a new synthetic division with those numbers, because we already pulled the negative 4 terms out. Anything that had to make that 0 of x plus 4, we already pulled those numbers out. So starting with 1, 5, 3, and negative 9, that's what's going to start your synthetic division with the next one, because they gave us 2 terms. So then you have negative 3 in the box because it was x plus 3, and then 1, 5, 3, negative 9 up top. Bring down the 1 again, do the same process. 1 times negative 3 is negative 3, add them, negative 3 times 2, put it up, add them, multiply negative 3 times negative 3, add them. You still get 0, so they'll still both work. Now you're left with 1, 2, and negative 3, so that returns to a formula. So you have x squared plus 2x minus 3. From there, you now only have 3 terms, and you're back to being able to factor, which should be the easy part, because we've been doing this for so long, a couple chapters. So then that one you go, 3 again, negative 3. What makes negative 3? Well, 3 and 1 is the only answers, but this time 3 is negative, but 2 is positive, so your numbers are a little different. This time 3, your factors are positive 3 and negative 1, because positive 3 minus 1 is 2, because that's what we need. So this one, you'll have 4 answers. See, for this, you had x plus 3 and x minus 1, but then you already had x plus 4 and x plus 3 over here. So you should have 4 different ones. And how you know that is the degree on the original polynomial. That's how number of answers you should have. And this one, again, you had x plus 3 twice, so I put x plus 3 squared, and then x minus 1, x plus 4. Again, the order does not matter. If you have one that's squared, I always put it in front. Okay, I don't think there's any on the back. Nope. There are extra examples if you want to do them. I'm only going to do them in class if we, need the extra practice. Hopefully you can do it. Just let me know.